Welcome to the first video on inverse trigonometric functions. So we're going to look at defining them, we're going to look at graphs. So we're going to look at how we actually come up with the inverse functions. And you'll know that we've done inverse before. We're now just putting this in place when it comes to trigonometric functions. So let's start with sine x. And the inverse is going to be sine minus 1 of x. So firstly, when we draw the sine curve, you will notice that this is a many to one, and hence, even though it is a function, its inverse is not a function. So that means we need to restrict the domain so that we allow our inverse to be a function. And so if we just take the section of the sine curve that goes from with the domain of minus pi on 2 to pi on 2, you can see that that section is a function itself, but also its inverse would also be a function. So a reminder that to be a function, you can use the vertical line test. That is, if you draw vertical lines and it only passes through one point. But to do an inverse function, if you test if it's an inverse, if you do horizontal lines, it also only needs to pass through one point. There is a tangent of y equals x, so that would assist with if we needed to find the equation of the tangent at that particular point. So here's our inverse. So the inverse function is a flip over y equals x. So, and a reminder that the domain and range are also the inverse or the reciprocal of the, they're the opposite of the domain and range for the function. So the domain now becomes minus 1 to 1 for the inverse. The range is minus pi on 2 to pi on 2. And y equals x is still a tangent for this graph. So that's the sine minus 1 curve. So for the cos curve, so here's our cos curve. You can see that the function is many to 1. So that means that its inverse is not a function. So if you were to use the horizontal line test, you'd pass through multiple points. So we need to restrict the domain for cos minus 1, for cos to get our inverse. So we're going to restrict it, the cos curve, from 0 to pi, and the range is from minus 1 to 1. So the range stays the same. And then what we're going to do is we're going to reflect this in the line y equals x, and we'll also change the domain and range, so we'll flip them over to get the inverse. So here's our inverse function. So you can see the curve has been changed. So it's now a cos curve up the y-axis. So the domain and range of the inverse for the inverse are the opposite to what they were for the function. And so we've got a domain from minus 1 to 1 and a range from 0 to pi. It has a gradient of minus 1 at the y-intercept. So if the tangent was there, the gradient would be minus 1. And finally, the inverse tan function. So we can see again the graph of y equals tan x. It is a function, but its inverse is definitely not a function. So we're going to need to restrict the domain over that. You can see our asymptotes are drawn in, and there's a fairly clear restriction. If we just take the middle section that crosses through the origin and restrict it to the asymptotes either side, you can see we end up with a, it allows us to have an inverse. So we restrict the domain from minus pi on 2 to pi on 2. The range is from minus infinity to infinity, and our asymptotes are at x equals minus pi on 2 and x equals pi on 2. So when we draw the inverse, so once again, we're going to flip our domain and our range. So now we've got asymptotes at y equals pi on 2 and an y equals minus pi on 2. and instead of the graph going upwards, the graph now goes sideways and approaches those asymptotes. So our new domain is, so now our domain is from -infinity to infinity, and our range, because we restricted it, is -π/2 to π/2, and the asymptotes that I talked about. In regards to inverse trig functions, you can also use the notation arcsine or arccos or arctan. So just be aware of that. That's all they represent. You'll see them come across. It just means it's the inverse trig function. And a reminder, in previous video, we've done the transformation of graphs, and the same rules apply. So if you add or subtract to x, you move it left or right, the whole graph. Add or subtracts to the function, the graph moves up or down. Multiply x by -1, it flips it over the y-axis. Multiply the function by -1, it flips it over the x-axis. If you replace, so with dilations, if you replace y with y over a, that's a vertical dilation of a multiple of a, and replacing x with the x over a is a horizontal dilation of a multiple of a. Thank you.